Hello and welcome back to my channel. In this tutorial, we'll be taking a look at how to do 2D rendering in screens and overlays. First of all, we'll be looking at different ways to change different stuff on the screen, like this, for example, and afterwards we'll be taking a look at how to dynamically modify it using the PoseStack. First of all, we can fill areas of the screen with GUI graphics.fill. This GUI graphics object will be available in any 2D like screen rendering, and you can use this to, well, in any GUI, you can use this to render stuff in 2D rendering, just as filling textures, for example. So we have here. So screens always have the width and height variables indicating the width like this and the height of the screen to render it. In this case, we'll be rendering from position 10 to width -10 and height 10 to height -10, with the color being hexadecimal, meaning you put them like this, which this color matches the same thing you would have in GIMP. But note that the first two are well, define alpha, therefore the transparency. Higher values mean less transparency. Now, and FF means zero transparency. That's 255. And now we can, this being RGB. So this would just be red with 255 red, 0 green, and 0 blue. And if we now hot swap this, you can see very much a red screen on the, well, red paint on the screen. Fill is a very simple method to render stuff on the, it's just plain color. Now we have also fill gradient, which requires yet another parameter being the color to, or you have the color from to color to. In this case, we can use color blue to color 2 as color 2, and this being from color 2 from 2. So if we hot swap it, you can see that the top is red and the bottom is blue, just as this shows. And the same as fill, don't forget to be adding the alpha values, otherwise it will not render at all. We can show that if we remove alpha from this and run it again, it just entirely disappears. So make sure you have these two alpha values set so it's actually visible. Now, next, after putting plain textures, we can also, well, plain colors, we can also put textures onto the screen by calling blit. This has quite a lot of different methods to use. First of all, we have resource location, p-address location. This is just the resource location relative to assets. So, for example, we have this 9-slice texture, which is located under assets. Then the mod ID of the resource location created. Then textures. You also already have to put that in, and then GUI. In this case, 9-slice between G. If you scroll in here, we can scroll up. You can see that this is a texture. Note that the default method requires a 256 by 256 pixel large texture. Otherwise, it will create kind of warped effects. And what you want is those are 6 integer parameters. First of all, we're going to put the 9-slice texture. Then we are going to look at the other parameters, being the X and Y position. U offset, this is the offset inside the texture. So U offset would be the X offset. So in this case, we want 0 because it's the texture we are trying to render is exactly at the top left corner. So we would first of all need to put this X position, which would, in this case, we are just going to put this dot width divided by 2, which indicates the middle of the screen, and reduce and remove should be 60. So we remove 8 to put it in the exact middle. And afterwards we need the U offset, which is 0. The Y offset is also 0. And last but not least, the width and the height being both 16. So we have 16 in width, 16 in height. If you don't believe me, pause the screen and look at it. If you wish to use other sized textures, you can also use, after putting Y, you put a 0 for the Z axis, and then put your size after here. This would then be the texture size. You also need to indicate the blit offset, which is the Z position with larger values being closer to close microphone. No, I didn't. With larger values being closer to the camera, well, to you as the viewer of the screen than smaller values. Next, besides blit, we also have blit 9 sliced, which is a it's a tool you can use to 9 slice a texture. In this case, we'll be taking 2, 2, 2, 2. Is that correct? We have width, height. That this width and height is not the size of your texture, but the actual rendering size. So we'll put it at 32, scaling it by 2 times. Left slice, top slice, right slice width is 2. Top slice width is 2. Hue width and hue height is 16. Texture X is 0. Texture height is 0. So this is in this case, this is the offset of the texture. In this case, this would be 0 and 0. Note that view width and v width height are the width and height of the thing to render in the texture. Slice width and heights are where to slice this texture to be cut into 9 pieces. In this case, we have all of them defined as 2. Therefore, it will cut this part, this red aquas part as one part, then this as the corner, this as the top, this is the top right, this as the right, this is the bottom, and so on and so forth. And if we now disable all this and refactor, you can also see it's currently very small, but we'll take a look at how to increase sizes when coming to the PoseStack. But you can see it looks very much the same as it before, with 2 and 2 being scaled down, and then these things being in the middle, a little bit larger. You can also increase the size, anything you want over here. Now, rendering textures is fun, but sometimes you want to tell something on the screen. So you have drawString, which you can use to draw string. Well, who would have thought? Draw string on the screen, with font being in a screen this.font. Otherwise, you have to either get it from Minecraft or as a parameter from the methods. String being, well, the thing to render, in this case, subscribe, and int and y being the position to render it. So in this case, we'll be taking it this dot width divided by 2, this dot height divided by 2, and last but not least, this last int is the color. In this case, you do not need the alpha values; they do not change anything. Now, if we update this again, you see that subscribe is written in the middle of the screen. Furthermore, we can change the color over here. Now turns red, and we can also make white again. Now, as you may have already noticed, there's yet another parameter you can give here, and that is drop shadow, which is currently hard to see. We'll be taking a look at this in a second, but you can see a shadow coming from, well, going into the bottom right corner as the light comes from the top left. And if you now disable shadows by doing this argument, it would actually look like this with removed shadow. This looks pretty bad, actually, if I say so myself. So that looks a lot better. Now, there's also a fun thing you can do. This fonts have the ability to show you the width of a string, a formatted text, or a formatted char sequence. What that does is it gives you the pixel width of a string. So if we were to put subscribe here and were to add that as an argument, that would be the text width. We can use this to focus the text you want to write. In this case, we can put this.width divided by 2 negative text width divided by 2, which should put it exactly in the middle, and you offset the height by 5 because text is usually 10 pixels high. So now it is exactly in the middle, not only rendered from the middle to the out, but rendered exactly in the middle. That's a fun little feature. The same goes for draw centered string, which basically does that internally. Now, next we have render item, but we have to put PGI render item. And this allows you to, well, render items onto the screen. We'll just be putting a new item stack of the items.diamond and then give it a count of 4. This will be used in a second. And you have to specify the item stack to render and the position to render. In this case, will just be width divided by 2 and height divided by 2. Yet again, rendering it in the middle. You have see the diamond here. What you also might have realized that the count we specified is not reflected in this. That's because this is their own render method, which is named render item decorations. Now you also need to specify the font here, and then add the item stack and yet again the position. Now, if we hot swap this, you can also see that the number amount that was in here is now being rendered as well, as you can see. Note that you can also define your own item decorations inside of the register item decorations event, which just is, you can just register an item decorator subclass, which gives you the font and the GUI graphics. So that's where you render this. Now, furthermore, after rendering item and its decorations, we also have render tooltip. Yeah, but we also have to put it here. Yet again, requiring a font as well as the item stack to get. There's a lot of loaders for this. First of all, we have one that just renders the tooltip of an item stack, then renders tooltip of a component and the option of the tooltip component, and a lot of more stuff. So we'll be taking the font component int, or we can also take this. We also have the stack already, and yet again requiring the size and the position. Yet again, this time this would be the mouse position. So in this case, we can just give it the mouse position. Mouse position is given in the render method, in most common render methods, not all, but in this case it is. So if we hot swap this, you can see we have now the tooltip of the diamond stack we had here following us around. There's also render component tooltip, which just is an overload for the render tooltip method, enabling you to render list of components without having to define a item stack. Yes. Next is one of the most advanced topics in this case. We have inventory screen. Render entity in inventory follows mouse. This mouse being, well, mouse being mouse, who would have thought? You have to register GUI graphics, then the position of it, in this case, this dot width divided by 2, this dot height divided by 2, and scale. Scale is commonly very large, considering it is rendered very small otherwise. Mouse X and mouse Y, you actually have to offset by the X and Y position of the rendering position. So in this case, we can put a 2f here. Considering this is a float parameter, we can also put floating point division here. And last but not least, the living entity to render. In this case, we'll just be rendering the make of player, being this. It may notify that this might be null, but it's never null when you are rendering inside a screen. Now, if we do this, add it to the game, and now it, yeah, well, I forgot to offset it by the should be this. No, that's the wrong direction. Now you have to offset it a little bit by, first of all, you have to modify it by the height and width, and then you have to offset it by the size, which in this case is 50. I took these values from vanilla when rendering their inventory, like in the creative mode tab or survival inventory. And now we're done with the basics of rendering. Now we'll be moving on to some more dynamic stuff and the PoseStack. First of all, we have the screen has a tick method. You can override to increase a tick count variable. This is very useful if you want to add something that is dynamic, like dynamic colors or similar. But we will not be taking a look at it quite yet because PoseStacks allow us for a lot better and more visual changes of this. You can get the PoseStack of a GUI graphics by putting pose and then putting that into the variable. Now this PoseStack allow us for a lot of different things. First of all, being pose.translate, and then you can translate just moves the entire rendering. So if we put this dot width divided by 2, this dot height divided by 2, and 0, the third axis is not very important considering that is just the distance to well, the screen overlay, and is not, well, does not really appear unless you are rendering different things in a different order, which may cause Z fighting if you're not careful. But commonly that shouldn't happen because things rendered later are translated later. So we can now translate this, and if we now were to fill something, so we just put -5, -5, 5, 5, 0xff for the alpha, and then just put in green. You can see now we have rendered a green sphere in the middle of the screen, although we rendered it from -5 to 5 with 0, 0 being up here and this being width and height. You can translate this. That's just moving it, but of course there's more. You can also use post. As you may have already seen from the selection, you can also scale stack, for example, by 2. And if you do that, it becomes larger. Not a big surprise. Coming ever so slightly larger. What the most fun part about this is you can make it dynamic by putting, for example, math.sign. This is just this sign value, well, it's trigonometry and stuff. And then you can just put tick count. And if you do this now, we should probably do the same. You can also do math.cosine of tick count to the other coordinate. We should probably also scale this with math.radians to degree, no, degrees radians, because the sine and cosine value both require radians instead of degrees, meaning we have to scale this to down to radians. And also a sine value always returns in the range of -1 to 1. You can see now it will oscillate getting larger and getting smaller again. We can also add something, a very other variable called partial tick, which is the partial amount of time passed since the last tick, with ticks passing once every 0.05 seconds, so 1 every 20th of a second, while render methods is called as much frames you have per second, considering this is how frames are generated for the screen to render. Now if we hot swap this, it gets just slight amount of smoother, because it is this partial tick just increases the amount of partial expression. Now furthermore, besides having scale, we can also do one more thing, being mulpose. And now we can use axis.z negative or z positive does not, well, z n and z p means standing for z negative and z positive, does not matter. And you may have already guessed, rotation degrees, its quaternions are a rotation matrix, which allows you to rotate stuff. In this case, we can just put tick count plus partial tick again. And now when we push this, it will now start to rotate, which looks, wait a minute, what? Is that the, what? Okay, what? Honestly, I'm a little bit confused right now. What is going on? I am just going to remove this. And as you can see now, it is just rotating around the z-axis. Z-axis being, as we already established, the z-axis coming from, well, it's basically the axis you're looking in. So translating in it does not really make any difference. But rotating around it makes a lot more difference. You can also rotate around the other axes. For example, you could put y positive in here, but as you may have, but this, we have to wait a second because rendering in the wrong direction is not good. This rotated around the vertical axis, which means it just oscillates just as scale that. That's not very helpful, so we only use ZP. Now note that translate, scale, and mulpose are not interchangeable. So scale and mulpose are. You can change the order of those, problem without any change. But if you translate, for example, if you translate after mulpose, it will go like out of the screen, because always where you are translated, so the pivot point is always where the PoseStack is translated to. So if the pivot point starts in the middle, it is also rotated around this. So if you then translate and then fill a relation later, this will not work. Same goes with scale. If you scale first and then translate and then will pose, the translate will be scaled, making it render outside of the screen on the top bottom right. So make sure you use translate first and then anything else, because that's the only way it will work. Now, last but not least, if you have a lot of rendering stuff you want and different rotations and different angles, it can be very hard to ensure that the scale is being removed, translation is removed, and multipose is removed, because you would have to multipose it back and all this stuff. And that's why it's a PoseStack. You are just able to create, not pose, but push pose. And then pop pose after you are done with a certain part of your code. So in this case, after we're done this code, it should just reset the matrix. And if we render some, oh, actually, now it's, we did just that at the moment. Now it just renders in the top bottom left, just as there was nothing there. If we translate it, and it's back to being large again. We can also wait. Oh no, I forgot to put 0 here. As you can see, after we pop pose, all these modifications like rotation, scaling, and all of this has been gone. So the aqua square I just rendered is only going to show up here. And that's about it. Now you open screens. In Minecraft, you open screens. This is a data generator. You should never open this from a data generation. But for the sake of example, Minecraft.get instance.set screen, and then you can put new test screen, for example. This is how you open a screen. This only works on the client, so ensure you're on the client if you're doing this, or otherwise you have to send a packet to open the screen. You can never open it from a server. This will not work. Same goes with the overlays. Just continue this. Overlays are registered under the register. What the hell? GUI overlays event, which allows you to register them below all, below, above all, which just changes the order of where things are registered, making it render in front of the chat or in front of the hearts in the bottom of your screen, such stuff. Note that this event has changed Neo4j, if I can find this. Note that in Neo4j you need to register GUI layers event, which basically does the same thing, just with a different name. This is for Neo4j. And if you have my library caplib installed, either on 1.21 or 1.22, 1.21.1, you would use register configurable overlays event, which just allows you to move the overlays you have registered. That's just a lot easier to work with for the user. So that is that. I hope this tutorial helped you creating fancy and magnificent screens, and have a great evening, or whatever time it is for you now.